Hey everybody, welcome to derivatives, basic derivatives rules. This is the quotient rule, okay? Probably the second most common derivative that we've taken so far. So we've done the product rule, we've done the power rule, and now on to the quotient rule. Well, the product rule deals with multiplying two functions, but what if we divide two functions? Okay, so by definition, the quotient rule tells us if you're going to take the derivative of the quotient of two functions f and g, it's going to be equal to g times f prime minus f times g prime all over g squared. Or we commonly write it as bottom times the derivative of the top minus top times the derivative of the bottom, all divided by bottom squared. So this is the rule I like to think about because this can be tricky. This is definitely the technical term, but in my mind you might hear of also low d high, high d low, but this is a better way for me to remember it. Alright, so I've got three examples to show you, so we'll try to get through these. I like all three of these. It's a good mix. So let's go ahead and get started on number one. Okay, so you want to find the derivative dy dx if y equals this. So our y equals 5x plus 2 over 6x squared plus x minus 1. Take that derivative. Okay, so you could label your functions, but I'm going to go ahead and take this derivative. So I'm going to say dy dx, that's going to equal bottom, right? Bottom, 6x squared plus x minus 1, bottom times the derivative of the top, the derivative of 5x plus 2, the power rule tells us that's just 5, minus top times the derivative of the bottom. So the derivative of g is 12x plus 1, 12x plus 1, all divided by bottom squared. Okay? Most of the time, you're not going to do anything with the denominator. Most of the time. We'll see an example where that's not the case. So could you leave it like this? Yes, depending on the text, but we're going to go ahead and take care of the algebra here. We're going to distribute the 5, so you're left with 30x squared plus 5x minus 5 minus, and let's use distributive property here too, which gives me 60x squared plus 5x plus 24x plus 2. Okay, so there's your distributive property, all over 6x squared plus x minus 1 squared. Again, I'm not doing anything with the denominator. So now some more algebra. So now distribute the negative, so you get 30x squared plus 5x minus 5 minus 60x squared minus 29x minus 2. All over that same g. We're not going to do anything with that denominator at this time. Okay, combining like terms will finally leave you with all three terms being negative. I get negative 30x squared minus 24x minus 7 all over that denominator. Okay, so that's a pretty long problem, but depending on how much do I have to simplify? Well, if you got a single term here, you probably can do it, but there's our finished problem. There's our derivative. So a lot of work for the quotient rule. All right, let's look at another example. So example number 2. This one will be, the next two will be quicker. Find f prime if f of x equals sine of x minus 1 over cosine x plus 1. So let's go ahead and rewrite f of x. And then we're going to remember that bottom times the derivative of the top minus top times derivative of the bottom. So f prime, signal the derivative there, bottom cosine x plus 1 times the derivative of the top, which is just cosine of x, right, minus top times the derivative of the bottom. Derivative of cosine is negative sine of x, all over bottom squared. Don't do anything with that denominator. Okay, so let's look. Distribute, you get cosine squared x plus cosine of x. So this is minus sine x times minus sine x plus sine squared x Okay, so subtract a 1, so this is going to be, so what we're going to do is distribute, so you have negative sine of x times 1. Negative 1 is sine of x. The minus becomes minus sine x. Okay, and that should be 1 term, 2 terms. Okay, that should be that all over cosine of x plus 1 squared. Not done yet. What? You're not done? Look, here and here, if you add those together, well, that's just 1. So the check plus check there equals 1, right? Cosine squared plus sine squared of x equals 1. So this is all going to equal, so this term and this term are gone, 1 plus cosine of x minus sine of x, all divided by cosine of x plus 1 squared. Okay? Example number 2 done. And we're at 6 minutes long video. Last one. Last one. All right, here we go. Could do this 2 different ways, but since we're doing quotient rule, we're actually just going to go ahead and do the quotient rule. I could bring this up and do a product rule, but this is quotient rule after all today. So f prime of x equals bottom times the derivative of the top minus top times the derivative of the bottom over bottom squared. Right? The derivative of x cubed is 3x squared. Okay. Now you have x cubed. I'm just going to move the 3x squared out front of the sign for proper notation. Oops, not sine squared, sorry, just sine of x. I was thinking about the last problem. Over x to the 6. Now notice here, notice there I multiplied that out. We have an x cubed and x squared here, so we could factor out the x squared. So I'm left with x cosine of x minus 3 sine of x, all over x to the 6. Now this is a one example where, oops, it'd help if I put it in the right screen. I'll factor out the x squared, so I'm left with x cosine of x minus 3 sine of x, all over x to the 6. So this is one term. First time I actually did this. So now these become 1. This is 1, right? And then this is x to the 4th. So our last step here is we just have x cosine of x minus 3 sine of x over x to the 4th. So those are 3 examples of the quotient rule. So if you have any questions or comments why I did that or how I did that, please let me know, and we will see you next time.